Hello and welcome to the start of our geometry class. Today we're going to look at section 1.1, which talks about the tools of geometry, kind of the building blocks really, and most of this first unit is really geared towards kind of building geometry from the ground up, which is a really good way to look at it. I've looked at multiple geometries, multiple different ways, and this seems to be the most intuitive, I would say. So today I want us to be able to identify points, lines, and planes. And as with most things in geometry, a lot of it's going to be based on some definitions that we have to start with. And I've gone over this, in every class today, and I think I've written different definitions every time. And the ideas are all the same, so we're going to stick with those. A point is a location in space. Okay, a point is a location in space. There's no size. We have to draw the point, but there's no width. Okay, there's no length. There's no height. There are really no dimensions, and that's why a point exists in 0 dimensions. And so we might have point A here on the paper, and we can call it that. If we were to try to identify it, we'd say that's point A, or you could just say A. Either one verbally would work. Obviously, saying that it's point A is a little bit easier for the person reading it to understand what you're talking about. A line is just a sequence of points spanning I'll say forever in opposite directions. And I do apologize, the pen being recorded lags a little bit, so sometimes it's a little bit harder to read. It takes me a little bit longer to draw it, but I'm doing my best to make sure everything works out. So for this, we might have what we typically think of as a line, and we are dealing with only straight lines. Okay, and I'm going to put points B and C on this line. And if I wanted to name this or call upon it somehow, I need 2 points that are on the line, so we're going to use B and C, with a double-sided arrow over the top. That's the symbol to mean line BC. Sometimes they'll give us like a cursive letter towards the end of the line, usually, somewhere around the line. If we have that, it's a lowercase cursive letter. In this case, it's an L. We could also say that it's line L. Or if you wanted to, you could say even that as line L. Okay, but those are kind of the 3 ways to name a line, either with 2 points, with a line, double arrow line over the top, the single cursive letter that identifies that line, or line and then that cursive letter. You could also say line BC, but we usually like the shorthand versions a little bit better. They're kind of nicer. So I'm kind of particular to those. And the last big one that we have is a plane. And we'll say that a plane is a surface extending to an infinite and infinite sorry, it's bugging me. I'm not used to it yet. To an infinite length and width. right, to an infinite length and width. So it's some sort of two-dimensional idea that goes on really forever in all four of these directions here. That's what makes up a plane, but usually we show it with boundaries, and that's not incorrect to do. It's okay, it all works out. In order to name a plane, we have two different ways. Option one is by a capital cursive letter that's assigned to it. So this one we have written here as plane P. That's sort of a cursive capital P. Or by what we call three non-collinear points. Now, in order to talk about what non-collinear points are, we probably need to see what collinear is, because non-collinear is just the opposite. So anyways, in naming this, we're going to have A, B, C being the 3 points that would define this plane. Now we need them to be, as I said, non-collinear, which just means, well, collinear means on the same line. So these 3 points being non-collinear just mean that they're not on the same line, because the idea of building that triangle between points A, B, and C kind of gives you that idea of it being a surface and actually covering up some area. So collinear means on the same line, and we wanted those to be non-collinear, just meaning not collinear, not on the same line. Okay. The last one is coplanar, which on that same idea means on the same plane. I've got to figure out a way to make this pen work a little bit better for me. So these 3 points up here, A, B, and C, would be coplanar but not collinear. So in classes, we had a pretty good talk about what's going on in this image right here, in this diagram. So we've got plane P. I see lines L, M, and N. We've got L kind of going horizontal, M kind of going vertical, and then N is kind of a weird one. You know, the talk was, why is this portion right here dashed? Okay, why is that showing a dashed line? Well, what this is trying to do is show a three-dimensional situation on a two-dimensional surface, right? Just watching this video, looking at the piece of paper, you can't really see 3 dimensions there because it's only a two-dimensional surface. We're trying to give the implication of a third dimension by building in some depth. And what it is this line N is not on the same level as this shape here that's making up plane P. It's actually coming down into the surface and then going behind it. And this dashed part is dashed because we can't see it. We can't see it until it comes out from hiding underneath. And so it comes out down there, where then we can see it again. So it turns solid again. That's why whenever you see dashed lines in geometry stuff, it probably means that you can't see that line. Okay, but it is there. So just letting you know that it's there. All right, so using some of the things that we've talked about, let's get to some of these questions. The first one says, give 2 other names for line AB. Okay, line AB is right here, and we want some other way to say, hey, this one right here, this is the line you want. That doesn't work all the time, so we want to find other ways to say it. I might use it as line L. I could say that it's line L. I could also just flip the A and the B to say that it's line BA. So there's 2 other ways. I do notice that C is also on there, so I could say like line AC. That would work just fine. Or CA or BC or CB. Excuse me. Just trying to get all the different methods out there. Okay. The second one says, name the intersection between L and P. Well, L is a line and P is a plane. A line and a plane can only meet so many ways. Let me try to get something to make a... Okay, so bear with me, but I have a piece of paper here, and I'm going to use a pencil. Okay, so line, plane. We can either have, if they intersect at all, okay, because we can have it like this, and right now these two don't intersect, and it's, I mean, I know you're looking at a video, so it's still two-dimensional, but they don't intersect, okay? That could happen. The line could be on the plane, right? Right now, kind of tough to tell, but my pencil is directly on, running the same direction as my plane, and it's on the plane. So that's one way that they can meet. And when they do that, they meet in the entire line. The other option is kind of like what we saw up above. The line could intersect the plane at a point. It could go through the plane. So I've got my eraser part of my pencil here. It's going through the paper. And so if they met that way, if they intersected that way, they would intersect in this point right here where the line comes through the paper. That would be their intersection. So if we look at this one, we have line L and plane P. Well, from what we can tell, line L is on plane P, so their intersection is just line L. And that was one of the two options. Either it was the entire line or the point that the line went through the plane, which line L doesn't look like it goes through it. It looks like it's contained in it, and so that's what we go with. Okay, the next one says, name the plane containing point E. Well, point E is right here. It is definitely the spot where line N goes through plane P, so we know for sure that plane P contains point E. There are also other planes that contain point E. Any plane that's described as being through point E, or as we talked about up above in naming planes, all those would also contain point E. So we're looking to contain point E. It's any plane P that we could talk about. The only way to make a plane that's not plane P right now is to involve point F, because point F is off of the plane, it's way below it, all the way out to where we can see it again. So you could say like plane EFD, right? That plane that would extend indefinitely in all those directions would also be another plane, and that one's not the same as plane P. And in fact, that one all the way except for right here should be dashed, because I wouldn't be able to see any of that. Except for you could argue this line between E and D, I would be able to see, but this one I can't see, and this one I can't see. They're below plane P. Okay. I also want to work a little bit on you drawing some things. Okay. So let's diagnose what we got going on here and try to make these drawings. I have QR that intersects S at T. So I've got plane S. And these don't have to be perfect. I have a lot of people stressing about, it's got to be this perfect, weird-looking, slanted shape. No, it doesn't. It's just a surface. Okay. It does extend beyond this. And I've got line QR that intersects it at T. Now, T, being just a capital letter, means that it's a point. And it's going to intersect the plane at a point. A line intersects a plane at a point when it goes through it. So we want to show that diagram. Something about like this, sort of. Kind of weird, but I want my line to go into the paper here at point T, and then extend beyond it, probably where I can't see it. And there are other ways to draw this. This is just one way. And we can have point Q, and then we need R somewhere else on here. Let's put it down below. It doesn't have to be below. There's no rule that said here that T had to be between Q and R, but that's just how I've drawn it. Okay, next one has a lot of stuff going on, but it's not really that bad. I see lines A, B, and C, D that intersect at point E. So that means I need two lines that intersect. And I'm picky about how they intersect. They intersect at point E. And this one's AB, so we got to have A and B on there somewhere. And this one's CD, so let's have C and D on there somewhere. And it says that all that is in plane A, and that's just how I read it. You might read it a little bit differently. So I'm just going to put all that in plane A. And so I need a little cursive looking A. Let's go with that. That's okay. Okay, so they meet in plane A. That's good. Also, I have point F that's coplanar with lines A, B, and C, D. So I want point F somewhere on that same plane, but not collinear with either. Just means that F can't be on AB and can't be on CD. It can literally be anywhere else. And there we go. Your homework is on the back or the next page, however you want to look at it. And let me know if you have any questions, but get that done, turned in, be good on day one. All right, have a good day, and we'll see you in class.